friends, welcome to Oliboard. I'm your quant faculty Priyanka here. So friends, we have already discussed the permutation and combination. Okay, so all those concepts will be same continued in the next topic, that is nothing but probability and statistics. Okay, now in probability, maximum of you might have come across this topic after your graduation for the first time. Okay, so you might not have dealt with this topic, so that is the reason we are going to discuss few of the definitions as well, because they can be asked as an objective in your exam. Plus we will discuss the question. Okay, so this topic will be covered in two parts, and do revise the concept of permutation and combination before doing this topic. So friends, let's begin. So what are things I'm going to cover in this? First, I'll be talking about the definitions over here, and then we will move on to the basic concept of probability, and then we will discuss few questions which can be asked from this topic. So second part will be dealing maximum with the types of questions which were asked in your previous year exam, and in this it is more theoretical based, just to make you understand the meaning of probability. Okay, so let us start with the first definition over here. Now, what is the meaning of probability over here? When I am talking about the probability, there are three ways how you can define this. First one is, it is nothing but the game of chances. Okay, so when you are talking about the probable value, so there are chances which you are talking about. For example, let me give you one example over here. I have a bag. In bag, I have suppose two red ball and one blue ball. Okay, now I'm figuring out the chance of getting one blue ball when I'm putting hand into the bag. Okay, so this is nothing but chance of getting the blue ball. That is nothing but the probability. Okay, or you can also say the fact that is probable, or a state of being probable, or a quality of being probable. So many times these things can be asked as a definition in your exam. So you should know, it can be anything over here. When you are talking about the probability, it can be any condition that is happening, it can be any quality that is happening, it can be state of being probable. Any of the value can happen when you are talking about the probability. Or I can, if I have to talk in the formula terms, I can say that probability is nothing but the ratio of favorable outcome upon total outcomes over here. Okay, so how many total outcomes are there? There are three balls. So there is possibility that I will get any three of the balls over here. So total outcome could be three, but I am talking only about blue over here. So my favorable event would be only getting the blue. Okay, so there are three ways how you can define the probability. Please remember this, probability is nothing but it is a game of chances. Okay, and anything can be probable over here. Fact can be probable, state can be probable, or quality of the object can be probable. Anything comes under the definition of probability. You have to mark all of the above in that case. Okay, or they may give you this definition over here. Okay, now when the question of probability arises, that is also important. So that depends on the types of processes. Now you imagine over here, when I'm talking about, suppose I have a coin. Okay, suppose if I have coin, when I'm talking about the coin, when you take any 1 rupee or 5 rupee coin, the coin is equally balanced. Okay, so same weight would be there on the top, same weight would be there on the bottom. Now imagine, suppose this is my coin, I'm just drawing the side view over here. Now, out of this two parts which I have shown over here, one part is very much heavy. One part is very much heavy over here. Now, when you are rotating this, it is very much obvious that it will fall on this side only. Okay, when you are keeping it vertical, if this side is heavy, obviously it will fall on this side. That means I'm definitely going to get only one outcome over here. Are you getting it? That is called as unfair trial. Unfair means you are not using a fair trial over here. Okay, so in that case, it is very much evident that you will get only one output over here. So what can I say? When results of all the trials are same, that is called as deterministic or a certain process. Okay, so many times this definition can be asked in your exam. So there, what is the definition? Deterministic or certain. Deterministic means which is already known, which is already known to you. Now, if you know that if I am going to toss and I am going to get head always, there is no meaning of those trials over here. Okay, so whenever we are talking about the probability, we always talk about the random process. We never talk about the deterministic process. When outcome is already known, there is no point in defining the probability. Okay, now what is the meaning of random or uncertain process? Result of all the trials are different over here. That means suppose if I take a coin again and it is balanced one over here, so it may fall on this side or it may fall on this side. You may get head or you may get tail. That means all the trial, when I'm first time doing it, I may get head. Next time I may get tail. Next time I may get head. Again I can get head also. So I do not know what I can get over here. So all outputs would be random, or I could say they would be different over here. So these are the two types of processes. Please remember the definition. Deterministic means you are talking about the certain output over here. And when you are talking about the random process, that means output can be anything. All outputs are equally possible. Okay, now there are two types of coins which will come from this. Now this can also come in the definition. If you are doing a toss or if you are doing a random process, it is very much important that the coin should be, the toss coin should be fair coin over here. What is the meaning of fair coin? The mass distribution should be same throughout the coin. Okay, so when you are throwing it, you should be getting any output. Okay, both the outputs should be equally possible over here. So it should be unbiased coin over here. Okay, so when you are talking about the fair coin, it is unbiased. Unbiased, biased means you are putting extra weight. Okay, biased means you are putting extra weight like this. Unbiased means not biased. Okay, that means it is the normal coin over here. It is equally weighted coin on the both side. Okay, so mass distribution here is same. Here when you are talking about the unfair coin, it is a biased coin. Unfair coin is biased coin. Mass distribution is not same throughout. Okay, so these two definitions are also important, fair coin and unfair coin. So whenever you are figuring out the probability, it is important that it should be random process and it should be a fair coin when you are dealing with the probability over here. Now, let us discuss few of the things over here. The tossing of a coin. Okay, now in probability, whatever thing is happening, that is called as a random experiment. Okay, whatever experiment you are carrying out, that is called as random experiment. Okay, so you observe something that is uncertain. So from this event, you should get some uncertain value over here. So when I am doing the tossing of coin, I may get head or I may get tail. Okay, so that process is nothing but a random process. Okay, now when you are doing that random experiment, you are going to get some outcomes. Whatever outcomes you are going to get, they are called as sample space over here. For example, when I'm tossing a coin, I'm sure I'm going to get two output over here. One can be head or there could be tail. There is no third output from this. So the overall sample space would be nothing but the outcome of the event over here. Similarly, when you are throwing a dice, you might be aware these dice have 6 sides over here, right? And 1, 2, then 3, like this all points are shown. So when you are throwing it, it is a random process. You all the values are, it is a fair dice. So you are going to get all the values equally likely over here. Okay, so equally likely means equal possibilities there. You may get 1 or 2 or 3 like this. Okay, so what is the sample space? Here sample space will have 6 points over here. 1 can come, 2 can come, 3, 4, 5, 6. So there are 6 events possible in this. Are you getting it? Okay. Now here when I am talking about the event, certain required situation out of the total sample space. Okay, so there are 3 things which you have to remember. Whatever experiment I am doing. What is experiment? Tossing of a coin is an experiment. Throwing of a die is an experiment. Now this experiment will give me some sample space. That means the total outputs possible. Okay, so what all are the total output possible here? 2 outputs are possible. Here 6 outputs are possible. Now what is the meaning of event? Event means certain specific value which is your requirement. So here you want head, that is the event. Here you want tail, that is one another event. Likewise, you may have any event. Here I may have event called I should get even number. I should get even number over here. So like this, you have to define certain event in this case. So for example, sample space of a dice I have written. Now what I'm saying, what event I want, event I'm showing by E over here. Event of getting even number. Even number means 2, 4, 6. Event of getting odd number 1, 3, 5. Event of getting greater than or equal to 2. Greater than or equal to 2. So what all are possible? 2, 3, 4, 5, 6. Likewise, you can try any combination. So can I say that event is always a subset of your total sample space? Okay, event will always come from a sample space and it is always a subset of the total value. So please make sure that you are understanding these three things over here. What is the random experiment? What is the sample space? And what is the required event in your case? Okay, now let me move on to the question over here. So random experiment, I have taken one random experiment over here. Okay, what is the random experiment? My experiment is throwing of a dice. Okay, throwing of a dice over here. Now, what all are the sample spaces or total outcomes? Total outcomes would be 1, 2, 3, 4, 5, 6. What is my favorable outcome or required outcome? Okay, so favorable event is nothing but the event which you want over here. What is the favorable event? I am defining it that what is the event of getting 6 on the die? What is the probability of getting 6 on the die? Now there is only one way I can get 6 when 6 falls on the die. Okay, so only one way is possible over here. Total 6 ways are given in this case. Total 6 values are possible. But what is my required event? My required event is getting 6 number on the die, which can happen only once over here. Okay, so what favorable outcome is 1. So what is the probability? Probability means 1 is my required value upon total outcomes over here. So please remember favorable outcome upon total outcome. Okay, let me give you one more example. Suppose if I give you the what is the possibility of getting the even number over here. Now what will be my favorable outcome? Even number when I'm talking about, it can be 2, it can be 4 or 6. Okay, and what would be the total number of event? 1, 2, 3, 4, 5, 6. So there would be total 6 events, but out of them, what do you want? The favorable event is getting the even number. So what will be your answer? 3 is the favorable value, 6 is the total value. So 3 by 6, that is 1 by 2 will be the probability. Are you getting it? This is how we calculate the probability of any event, favorable upon total value. So probability is defined over here. This is defined as the event possibility upon the total sample space over here, 1 by 6. Now there is another probability, that is probability of a complementary event over here. Okay, this is nothing but the complementary event, or I can say that the negative probability. Now how you calculate the negative probability? Now when I'm saying probability of getting 6 in this case, what will you say over here? Probability of not getting 6. Probability of not getting 6. Now why I'm telling you this is because total possibility is 1 over here. So when you are tossing the coin, either you will get 6 or you will not get 6. Okay, other than this anything cannot happen. Either you will get 6 or you will not get 6 over here. So these are the only two probable events. Okay, so when you are talking about the second event, not getting, you can simply subtract it from 1 and write down your value. Okay, so 1 minus PE is 5 by 6 over here. So not happening is represented by this dash over here, or you can represent it using the bar. Okay, now using this, there are few properties which you should know. The first property of probability is whatever total event is there, the probability is always 1 over here. Okay, total probability of event is always 1 over here. Okay, for example, let me give you the dice. Okay, when you are rolling a dice, you are going to get 1, 2, 3, 4, 5, 6. Right? Now, what is the probability of getting 1? Probability of getting 1 is only 1 by 6. What is probability of getting 2? 2 means only one event. So that is 1 by 6 again. Similarly, probability of getting 3 will be 1 by 6. Probability of getting 4 would also be 1 by 6. 5 would also be 1 by 6. And probability of getting 6 is also 1 by 6. Now this is my total event. Why it is total event? Because these all are the output. Other than this, there is no other output. So if you add all these values, 1 by 6 plus 1 by 6, 6 times over here, definitely you are going to get 1. That means the total probability of event is always 1 over here. Are you getting it? Similarly, what is the minimum possible value of an event? 0. Okay, suppose if I ask you what is the probability of getting 7? Now when you are throwing a dice, 7 can never come, right? So what is the probability? 0 is the probability over here. Are you getting it? This is how the minimum probability is defined. So I can always say probability is always between 0 to 1. More than 1 probability is not possible. So always your probability value lies between 0 when event is not possible, and when event is certain over here, it is probability of 1. Okay, now what is the probability of 1? For example, let me give you example. I have a bag. Okay, I have a bag. I have 2 red balls in this. I have 2 red balls in this. Now, if I ask you what is the probability that if I withdraw one ball, if I take out one ball, the ball is red. Okay, now anyways, there are red balls only. Both the balls are red. So, what is the probability of getting red ball? 100% I am going to get red only. Why? Because there are only red balls. Okay, so what is the probability of getting red over here? 1. If I ask you what is the probability of getting blue ball? Now there is no blue ball at all. That means the probability would be 0. Are you getting it? So this is the basic definition of your probability. So I have just written all the definitions on the same side. So for example, whatever experiment or trial is there, whatever outcomes you are getting which are uncertain over here, or I have told you the random process, this is called as experiment or trial. I have given you example, for example, tossing a coin, selecting a card from the deck of card. So there are 52 cards, right? So this topic will be dealt in detail in the second part. Or throwing of a dice. All these are nothing but the trial over here. Now what is the meaning of event? Whatever single outcome of an experiment you want, that is called as event. For example, getting ahead. Getting ahead, whatever requirement you have, that is defined under event. Outcome means all the possible outcome you have to write over here. Okay, so when you are tossing, you may get head or tail. Those are the outcomes. The output, whatever you are getting, that is called as outcome. When you write all the outcome, that is sample space over here. Okay, so sample space, for example, when you are tossing, this is a sample space. When you are rolling a die, this is the sample space. When you are taking out a card, you know that card has 52 cards, so that is the sample space over here. Okay, now what is the meaning of complementary event? Non-happening of the event over here. For example, getting 6, not getting 6. Okay, so how will you calculate this? 1 minus that value. Impossible event means the probability is 0 over here. It is not at all possible. For example, getting 7 on a die. Okay, getting 7 on a die is impossible event. So these all are the important definition. They may be asked in your exam. Now there are 2 more definition which have been asked in your exam in few years. So you should know that one is mutually exclusive event. What is the meaning of mutually exclusive event? But please understand this. Now, when you are doing any event over here, when two of the things cannot occur simultaneously, that is called as mutually exclusive over here. Let me give you example. So they are also called as disjoint event over here. For example, when I'm throwing a coin, I can either get head or I can get tail. I cannot get both the things at the same time. Okay, are you getting it? So they cannot occur at the same time. So both of the things cannot occur at the same time. Head and tail cannot be present at the same time. Either this will be there or this will be there. So these are called as two disjoint event. Okay, or mutually exclusive event over here. So whenever you have to calculate probability over here, in this case you have to add the values of probabilities whenever it is a disjoint event. Now I have given you the example in this case. When you are tossing a coin, event of getting head and tail are mutually exclusive because they are not possible simultaneously over here. Okay, so that is what they have given you. The probability of getting the head and tail simultaneously is 0. So both of the events are separate events over here. Now similarly, in a 6-sided die, the event of getting 2 or event of getting 5, both are different events. I cannot have 2 and 5 at the same time over here. Are you getting it? Now suppose you are throwing 2 die. Suppose you are throwing 2 die over here. Now if I ask you what is the probability of getting 2 or 5? 2 or 5. Now when you are throwing 2 dice, there is possibility that you will get 2 and 5 together also. Here you will have 2, here you will have 5. So these two are not mutually exclusive now. Okay, now here it is not mutually exclusive. So if I ask you what is the probability of 2 or 5, you cannot write 2 for this and 5 for this and add them. You cannot do it like this. Okay, you cannot write probability of 2, probability of 5. You cannot do this individually because you have to take 2 here, 5 here, 2 and 2 here, 5 and 5 here. So there would be many possible events in this case. Okay, so these are not disjoint or these are not the mutually exclusive event. I hope it is clear now. So this definition can be asked in your exam for solving purpose. Mostly you will not need this concept. Okay, so just remember the definition when both the things cannot occur simultaneously. Now what is equally likely outcome over here? When you are talking about the equally likely outcome, the meaning of equally likely outcome is nothing but the all the possible outcomes are equally possible over here. So for example, equal probability of occurring is known as equally likely. So when you are taking a fair die over here, fair coin, you may get head or you may get tail equally. So these are called as equally likely events over here. So please remember these two definitions. They may be asked in your exam. Now let us solve few questions based on these topics. Okay, so few questions are there on your screen. First one. In a bag, there are 5 red balls, 3 green balls, 7 yellow balls. What is the probability of drawing yellow ball from the bag? Now let me write down. There are 5 red ball, 3 green ball over here, 7 yellow ball. Now what is my event? I want probability of drawing yellow ball from the bag. So what we write? We write down the favorable outcome over here upon the total outcomes. Now when I have how many ball I have? 7 plus 3, 10, 10 plus 5, 15 ball are there. The total how many ball can come? 15 possibilities can come. Total 15 possibilities can come. Out of that, what is my favorable? What is my required event? I want yellow ball. So how many total possibilities are there? 7 possibilities are there that I will get the yellow ball. So what will you write? 7 by 15 would be the probability. I hope you must have understood how to apply the definitions which you have learned so far. So 7 by 15 would be the answer. Now let us move on to one interesting question. I think you must have understood now how to calculate the favorable event and how to calculate the total events. Now this is interesting question. What is the probability that a leap year selected randomly has 53 Sundays over here? Okay, so 53 Sundays over here. Now what is the meaning of leap year? It will have 29 days in February, or I can say there would be total 366 days. General year has 365, but here you will have 366 days. Okay, now you want 53 Sundays over here. Let me first calculate if 52 weeks are there. How many days would be there? 52 into 7. 52 into 7 means if you calculate the value, you will be getting 364 days over here. 364 days would be definitely there. Okay, because your year is of 366 days. Out of them, 364 would be always there. Now, whatever 2 days, how many days are remaining? 2 days are remaining. 2 days are remaining over here. Now, out of them, what is my required probability? I want 53 Sundays. So, when I am talking about 52 weeks, 52 Sundays would be there. I want additional one over here. Now, these 2 days, how many values are possible for these 2 days? Okay, so you can try these values. Monday, Tuesday can be the pair. Okay, or you may have Tuesday, Wednesday. Then third possibility is you may have Wednesday, Thursday. Right? So these 2 days can be any days over here. Fourth one can be Thursday, Friday. Then you will have Friday, Saturday, and last Friday and Saturday, then Saturday and Sunday, or that the last possibility would be Sunday and Monday. Okay, Sunday and Monday over here. Now what is given in your question? You want 53 Sundays. So what is the probability of getting Sunday? The total outcome, if you observe over here, how many total outcomes are possible now? 7 outcomes are possible. Out of them, which all are my favorable one? I want 53 Sundays. Means in this combination, Sunday should be there. Now either Saturday, Sunday can be there or Sunday, Monday can be there. So 2 by 7 would be the required probability. Did you understand? So figuring out the favorable event and required events, that is very, very important. So the total sample space as well as the required value you have to figure out properly, otherwise you will not get the correct answer. Let me move on to the next question over here. Two coins are tossed. Find the probability that two heads are obtained. Now when two coins are tossed over here, what all are the total cases? So when you are talking about the total cases over here, how will you calculate? Either I will get head head, or I will get head tail, or I will get tail head, or I will get tail and tail over here. Okay, now what is your required cases, or I can say favorable cases? The favorable event they are asking is probability that two heads are obtained. That means HH only. Okay, so you can manually see here. One is the favorable. Total outcomes are 4 over here. So 1 by 4 would be the answer. Now it is not always possible to write down all the possibilities. Okay, for example, if I give you 4 coins are tossed. 4 coins are tossed over here. So how many outcomes are possible? You cannot manually write head, 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 head and head, 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 tail. Likewise, we cannot write down the possibilities. Okay, so how we calculate the total value? You have to write down that there are 4 coins over here. Now each can have 2 output. Either it can be head or it can be tail. Similarly, this can have 2 output, this can have 2 output and this will have 2 outputs over here. Now I am tossing all of them together. Okay, so I am tossing them at the same time. So you have to multiply these values. Whenever you are saying that event is occurring simultaneously or at the same time, you have to multiply all the values over here. This is called as fundamental principle of multiplication. Fundamental principle of multiplication over here. Whenever events are occurring simultaneously or at the same time, you have to always multiply all the possible values. That is fundamental principle of multiplication. So here total values would be 16. If I ask you what is the probability of getting all heads in this case, your answer would be 1 by 60. So please remember how to calculate the total number of cases. Now let me discuss next question over here. Tickets numbered 1 to 20 are mixed up. Then ticket is drawn at random. So total events, how many events are possible over here? Total events you can say 1 to 20 means 20 outcome can come over here. 20 outcomes are possible in this case. What is the probability that ticket number drawn has multiple of 3 or 5? Okay, so you have to write down all the possibilities which are multiple of 3 and 5 over here. So it can be 3, it can be 6, it can be 9, it can be 12 or it can be 15 over here and 18. So between 1 to 20 you can observe all these numbers are divisible by 3. When I am talking about divisible by 5, how many outcomes? 5, 10 or 15 or 20. 5, 10, 15 or 20, these are divisible by 5 over here. Now there is one number which is common. 15 is written between these two values. So these two values are not mutually exclusive. Okay, so you cannot directly add this. Okay, you cannot add 3 and 3, 6 plus 4, 10. You will get wrong answer over here. Okay, because these events are not mutually exclusive. There is something common between them. Okay, so what you have to do? You have to count them manually over here. 1, 2, 3, 4, 5. 6, 7, 8 and this event is counted as only 1, that is 9. Okay, so if you add all these values, these are 5, this is 5 plus 3, 8 and this event I am considering only 1. 5 plus 3 plus 1, that is nothing but 9. So 9 is the favorable cases over here and total number of cases are 20. So what would be your probability in this case? 9 by 20 will be my probability. So you have to be very careful whether event is mutually exclusive or not. Otherwise, you have to subtract the common part. Directly, you cannot add the probability. I hope it is clear. Now, let me move on to the question which you have to do using a combination concept. Okay, bag contain 4 white balls. Okay, 4 white balls, 5 red balls and 6 blue balls over here. Three balls are drawn at random from the bag. So you are drawing three balls. Now I have told you, in case of combination, whenever you are choosing something or selecting something, you have to use combination. Okay, so when I'm choosing three balls over here, what will you write in denominator? Out of the total 15 balls, 6 plus 4, 10 plus 5, 15. Out of the 15 ball, I'm choosing three balls over here. So my total cases would be 15C3. Total cases would be 15C3 over here. Now what is your required event probability? That all of them are red. So how many red are there? 5. So I want all the 3 to be 5 red over here. So out of these 5, I have to select 3. Okay, out of these only red, because all of them are red. So I have to write 5 total red are there. I want just 3. 5C3. So like this, now I told you how to evaluate this. Count this 5 for 3 numbers. So 5 into 4 into 3 divided by this factorial number. So 3 factorial. Divided by here also you will count this for 3 number. 15 into 14 into 13 divided by 3 factorial. You can cancel this. So you will be getting your answer 5 3s are 15. 3 will get cancelled over here. You can write down 2 7s are and 2 2s are. So what are you getting over here? 2 by 91 would be the probability. So all of them are red. The probability would be 91. So please remember how to use the concept of combination over here. We'll be practicing more questions based on this combination itself. What is the probability of getting sum of 9 from two throws of a dice? So whatever I have told you for the coin, same will be applicable here. So there is one dice over here and the second dice over here. Now this can show you 6 outcome. This can show you 6 outcome. Now I told you this and this, both the dice are thrown simultaneously. Means I have to use fundamental principle of multiplication. So here total outcome would be 36 over here. Now, what is your favorable outcome? Favorable would be you want sum of 9. So, for favorable, I have to figure out which all cases are possible. So, when you are saying sum of 9, either it can be 3 and 6, it can be 6 and 3, it can be 4 and 5, or it can be 5 and 4 over here. Are you getting it? So, you cannot go beyond this. If you write 2 over here, this will become 7. So, 7 is not possible. So like this, you have to reduce the value in this case. Okay, so these all are the 4 favorable outcome. Total outcomes are 36. So what is my probability over here? You have to write down the favorable cases upon total cases. So favorable would be 4 by 36. That is nothing but 1 by 9. So this is how you have to evaluate the probability in this case. So figuring out the total sample space and the required sample space is very, very important when you are calculating any probability of the event. So this is what I have for today. Let us discuss few more questions which were asked in your previous year exam in part 2. So stay tuned with Oliboard. Thank you guys.